Record. Okay, cool. So, what we're going to be doing is we're continuing on with SOHCAHTOA, and we're getting now into more of the real life uses for trigonometry. You kind of saw that at the end of the homework assignment that I had you do yesterday, where you had to find values involving the playground slide, and then I think you had to find the height of something too. So I'm going to break up section 4 in our book into 2 parts. Today is going to be really easy. Hopefully it's pretty short as well. And then tomorrow is where we're going to get into some of the more difficult questions. I just thought it'd be a more natural separation to keep those apart from each other. So the first thing was just to show you some of the tools that are using angles and trigonometry. Now, the protractor is pretty obvious, so I didn't feel the need to include a YouTube video for that. But then the one down at the bottom is called a sextant, and something interesting, this is actually not the same one from the Titanic, but it's a replica one from the Titanic. I think just between all of you and me, though, I would say, considering what happened to the Titanic, I don't think you want to take anything from that ship. And then the one over here on the right, actually, it's supposed to be on a tripod. And it's called, I'm going to try to pronounce it correctly, a theodolite, I think is how you say it. So it normally goes onto a tripod, and that's used as well. The sextant is usually used to measure distances, especially for sailors and for captains of ships. The theodolite is used more for like ground surveying. So like if you're making a building, you're trying to figure out like how far apart are 2 distances, or the theodolite also is useful for finding heights. So what I've got are 2 videos. One of them, a professor from, I think it was Harvard, explaining how to use a sextant. And then the other one is a guy from Australia who's explaining how to use a theodolite. So gotta remember which videos. Oh, yeah, duh. Okay. So here's the sextant video. I don't think it has audio right now. Oh, and I paused it. Oops.
I can't hear it.
For me. Yeah, even for me, it's really quiet. I'm going to try maybe. I don't know if it's because it was in the YouTube app or not, but I'm going to try it over here as well. Hopefully it goes better. Still really quiet, isn't it?
Yeah.
Well, that sucks. Anyway.
Did you share audio?
No, I mean, it's really quiet for me, too. Like, Adam, you're louder than the video.
Really?
Yeah.
Well, that's not saying anything. I'm loud.
Well, okay, that's a disappointment. I'll try to explain. So basically, you can kind of see there's almost like a telescope or binocular tool that is on there. And I'm waiting for him to show the sextant again. Just show me the tool again. Okay, so he is pointing out then that you use the telescope and you want to aim it at the horizon, and then there are mirrors there that you adjust, and you're going to use the mirror then to move an object such as the sun, and the tool actually then uses the mirrors to move that object then to be on the horizon as well. And down at the bottom, when he was sliding that thing back and forth, that was going to be kind of like the protractor. So then you can find the angle by using that tool, and the mirrors move the sun to be then at the other point you're looking at. then you can look at the angle, and then you can use trigonometry in order to figure out either how high is the sun or how far away are you from the horizon. So that's pretty much how a sextant works. And then hopefully the other video is a little louder. If it's not, I'll just have to do the same thing again. Still kind of quiet, isn't it? How's the audio?
Nothing.
I can't hear it. Wait, hold on.
How do you share audio then?
I don't know. I just see Senor do it.
Ooh.
Senor's just like, can you hear it? And we're like, no. It was like, oh yeah, I forgot to do this. Share video, I think.
Well, I'm wondering if that shares a video then from my...
Camera roll.
Yeah, I was wondering if that was going to be sharing something from my camera roll. Because it's like... Yeah, because it's like, it's giving me the option that I could take a... Yeah, so like, you can see my cat again. I don't think it's that. That's too bad. I don't know what it is. Well, this has been a disaster. So, okay. Well, here's what I'll try to do. I guess kind of the same thing. Is that, yeah, he's saying he's able to scan it horizontally, and then they're also going to show how to do a vertical angle with it.
Did you share a screen?
Am I showing my screen again? Did I forget?
No, I don't.
I only
My
see
bad.
profile pictures.
Here, I got it again. Here, I'm going to try to... Okay, so there he is with the theodolite. And so what he's going to do first is he is going to sweep it horizontally so he could find the distance between those two white cubes that are on the ground. So what he does first is that he lines up with the first one, he turns it on, it records the angle that it's currently at, and then he rotates it to the other one. Make sure that he can see it through kind of like the binocular, the telescope part. Yeah, so he said he got 41 degrees, 20 minutes, 55 seconds. And so minutes and seconds are smaller measurements of degree, they're parts of degrees basically. So then what he could do from there was that if he knew the distance to either of the two cubes, he could have then solved for the distance between them. And now he's doing the same thing to find the height of the corner of the roof. And so he says the angle measure he found was about 82.5 degrees. And so with that one then kind of a similar thing. You find how far away were you from the object that you were trying to get the height of. You've now got the angle measure, and then you could use trigonometry with that as well in order to find the height of it. So those aren't all the tools that use trigonometry and angles, but those are just a couple of them. Those are the ones that the book specifically talked about. So I attempted to show you some videos of people using them. At the beginning, I mentioned too, some of the other videos I wanted to show you, at least that had other people than just white men in them. It was more like how to set up a theodolite. And I'm like, okay, that's cool, but that's not the point. I don't need to know how to put the tripod together. Or like I said, another one then was like a professor talking for like 30 minutes about how to use a theodolite, and I was like, that's not really what we're going for here either. So, okay. Now getting into some of the questions then. So, two phrases that you're going to need to be able to recognize then will be the angle of elevation and the angle of depression. And so basically what you're looking for here is, well, if you think of the word elevation, you're thinking kind of like height, how high is something. And so that's how I know then that angle of elevation means that we're going to be going up. And then the word depression, I know you're kind of thinking the initial one is more like being sad, but a depression also means kind of like an indent. If you press into like Play-Doh or putty or clay and you remove your finger, you've made a depression. And so that is when we are going to be going below the horizontal line. So that's basically what we're going to need to know. That's helpful because a lot of times for these questions, you're going to be given a word problem with no picture. And sometimes it will actually say angle of elevation or angle of depression. So that kind of helps you understand how to draw your triangle. Okay, so I'm going to move on then. So for example, here, we are going to find the height of the building to the nearest foot, and it says we're supposed to assume that the man that is looking is 6 feet tall. So what we know from what we usually do is we should label the 3 sides of our triangle. So I can tell that where the 90 feet is, now there's no, here, let me draw it in. There's the height, and there's the right angle. So we know then that down at the bottom, that is our adjacent. The line of sight will be our hypotenuse, and then we've got our opposite side. I'll use white so it's easier to see. Our opposite side then is going to be the height for the building. And from that, we know, since we're trying to find the height, I'll put that as little h, we need the opposite and the adjacent. So no hypotenuse there. Hey, Adam, you want mind muting your mic? It sounds like there's a ton of feedback coming through yours.
Whoops.
Okay, that's a lot better. Thank you. So, what we're going to do then, since we have opposite and adjacent, that means that we're going to need tangent. It is going to be tangent of 40 equals opposite over adjacent is h over 90. I've told you always put it over 1 and then cross multiply. So we will have h equals 90 times tangent 40. And then I'm just going to type this into my calculator. And what I get is that the height was 75.52. Then the next thing is that it said that we're supposed to also include that the man is 6 feet tall. So of course we're going to get then 81.52. And it said round to the nearest foot. So this ends up being a building that is 82 feet tall. Also, I don't think the picture is very representative. That appears to have a lot more height than 82 feet. But that's how we would be able to find the height then of the building. Okay, so I'm going to move on to the next one, if that's okay with all of you. So now that we have found that, what I want you to do then is I want you to find the length of the line of sight. So you're going to be finding the hypotenuse now. And so it says you're supposed to do it both ways. I don't really care if you do it both ways. Just pick one of them. Preferably the second one, since that's what we're actually covering in this chapter. But if you can go ahead, solve for that, and then if you would like, you can put your answer in the chat, and I'll let you know if it's correct. So I'll give you all about a minute to do this. If you all were able to read that on my tablet, it's because Adam asked if we had class, and I said no. All right, so if it's okay for all of you, I'm going to go ahead and I'll do the second one. I don't think it's as interesting to do the Pythagorean theorem, although that is useful just to check our work. The reason I want to do the bottom one, though, is I want to address something that often happens. So earlier we solved for that 75.519. Now we're not including the height of the man because, again, we're doing it from his line of sight. If we were to include his line of sight, or I'm sorry, if we were to include his height, then the blue line that I just drew in would actually be part of our triangle, and we'd no longer have a right triangle. So we can't use that. Excuse me. So instead, what we're going to do, we're going to exclude his 6, and that's why we're going to have that there. I noticed in the book made a mistake with that, and the book actually did use the 81.519, so that wasn't good. Anyway, what we'll do, we've got these two measurements already given to us, the 90 and the 75.519. Well, what if we did the last question wrong? Then when you are going to solve this for, I'm going to call the hypotenuse x, if we were going to solve for x, then the problem that we run into is if this was wrong and we solve for x, we're guaranteed to have x wrong as well. Whereas if we say, you know what, we're not confident about that one, so let's ignore it. Let's instead stick with the number that was given to us and we know for a fact is correct, then that gives us a better chance of having the correct answer as well for x. So that's just my personal preference. Honestly, how I grade is if you show me the correct steps anyway, even though your number at the beginning was wrong, I'll still give you credit for it. You've seen that on some of your tests already. So it's not as big of a deal with me being the teacher. However, I know that there are definitely other teachers, though, that aren't quite as generous. I actually remember when I was in school, I would make that mistake, and my teacher would say, well, you got the wrong answer, so it's wrong, so you don't get full credit. And I would be upset because I had maybe done, let's just say, I did sign correctly, but they didn't give me credit for it. So anyway, as I said, we're going to ignore the 75.519. If we label the 3 sides again, we still have adjacent on bottom, hypotenuse is x, opposite is the one that we are ignoring. So in this case, then we are going to use cosine of 40 is equal to 90 over x. Put over 1, cross multiply. We'll have x cosine of 40 equals 90. We'll divide both sides by cosine of 40. And when we put that into the calculator, we should get 117.49. And the units were feet. And it says to the nearest foot again, so that would actually bring us to 117 feet. So that would be useful for, let's say we need to run a support cable from where a person is standing all the way to the top. Not sure why. Maybe you're filming a movie and somebody's supposed to slide down that cable. But that's how you would be able to calculate that distance then. Is it okay for me to move on then? Yeah, okay. So similar question then, I want you to go ahead, find the height of the tree in this picture. Once again, I'll give you a little bit of time and then I'll show you the answer. All right, so hopefully you were able to get this one. So 20 will be, there's no right angle there. 20 will be our adjacent side. The height is the opposites. We don't need hypotenuse here. So we will have tangent of 32 is equal to the height over 20. We cross multiply, so we get h equals 20 tangent 32. And we get the height is 12.497. I'm kind of amused that these questions keep telling us to round to the nearest unit when all these numbers seem to be right in the middle. Honestly, I'd rather say it's 12.5, but we're supposed to round down, so it's 12 meters for that. All right, so I think I've got just one more. Oh yeah, so this was what I wanted to show you was for a lot of these questions, they end up being word problems and you're not given a picture. So it's up to you to be able to identify what you need to draw so you can solve it. So it's really important that you understand the context of the question. You need to be able to visualize what you are being told. So like this one is saying an airplane is approaching a runway to land. If the airplane has an elevation of 5,000 meters and is 8 kilometers from the runway, what should its angle of depression be to descend at a constant rate? So we're talking about an airplane. I'm going to draw a really terrible airplane here. So there's the airplane. And then what we're going to do is we're going to have a runway somewhere. So there's our runway. And between those, that's going to make our triangle. And I'm looking at this and I see that it's at an elevation of 5,000 meters, but then it also says it's 8 kilometers away. So this part is, it's a little, well, we got to change our units, honestly. So we have to figure out if we want to be using both kilometers or both meters. And I guess maybe just smaller numbers seem to be a little bit easier for us. So if we've got 8 kilometers down there, well, 5,000 meters, that's going to be 5 kilometers. And here's where this type of question becomes a little tricky. Where a lot of people have had confusion in the past when I've taught this is that they think of angle of depression, and they automatically put the angle there. But that's not going to work. We have to go back to our definition earlier, which, oh, it's over here. It's the angle below a horizontal line. And so down here you can see, well, here's the horizontal. It's between our diagonal line and the horizontal. The issue that we have with what I just drew here is that we actually put it between the diagonal and the vertical. So it turns out that this is the wrong place for theta, because theta is actually supposed to be there. So we just need to be aware of that then when we are trying to solve a question like this. The angle of depression is actually going to be right there. So what we really should have been using for our triangle is the one that's the dotted line. So in other words, then I can move the 5 there, I can move the 8 there. So I'm not going to use the triangle there, I'm going to use this one here. Okay, now that we've got that cleared up, then we can go ahead and we can solve this. Opposite side is going to be our 5, the adjacent side is the 8. Once again, we're going to need tangents. You may have noticed the majority of these questions are going to involve tangent. Usually, we're not worried about the diagonal. We don't usually worry about the hypotenuse. So don't assume that it's tangent every single time, but it's going to be very common that tangent is how we're going to solve these. So tangent of theta, opposite over adjacent, is going to be 5 over 8. We are going to do the arctangent of both sides. So that's going to be that right there. And then we are going to use the calculator to finish solving that. And that ends up being about 32 degrees. It's 0.01. I guess my numbers aren't very realistic. That's kind of steep. That's actually, yeah, that's kind of, we're going to say the plane's going in for a crash landing. Yeah, so that's what we would get then. So that angle that, when it said angle of depression, that's the angle that we found. That was 32 degrees. Likewise, I don't know if you remember this, but then from when we have talked, we talked a little bit about similar triangles already, and this angle here and this angle are actually the same. So if we found 32.01 was theta there, 32.01 ends up being that angle down there as well. I don't think that's not necessary for this question, but it could have been useful, I suppose. So anyway, that is everything. I told you I was gonna try to have us finish a little early today. So I've assigned only 4 questions, just giving you a heads up. I think number 3 is the most difficult one, just because there's more work involved compared to all the others. So just be aware of that as you're solving it. I didn't put any optional questions, but again, it's only 4. So that is everything. You all can head out. So have a good day.
Bye. Thank you. Bye.
Thanks. Bye.
You're welcome. Bye.
Bye.
Bye.